Okay, this is a pretty simple video. I wasn't going to do it, but it might help somebody, so I'll do it. I've got a lawn tractor that I converted mostly to LED lighting. You can see my snowblower intake chutes video for a view of what I did with that lawn tractor. Basically, I replaced this type of, although clear, not yellow, of course, but the same number bulb. Well, actually, these are double. Yeah, these are double based. So scratch that. The ones with the single base, the 1156s, I believe they are, or 1158s maybe, with the single tip on the bottom, single filament bulb. Anyway, that's what the tractor takes for its front headlights. They're not very bright. They use, considerable power. I wanted to be able to leave the tractor lights on without the engine running when I'm sometimes when I'm logging and I get into the late evening. I want auxiliary lights in the tractor to see by while I'm finishing up my logging duties. So I bought the ones you'll see in that video if you look at the video. Eventually they burned out on me, and I blamed it on these little reflectors I made for those bulbs. The bulbs kind of nested too deep into the reflector of the stock reflector, so I needed, I kind of augmented it. Maybe that metallized aluminum, metallized mylar might have caused a short and made the bulbs go out. I don't know what happened. More likely, my battery was going bad in that tractor, and possibly it just wasn't able to properly regulate the voltage anymore. So that might be why I burned out the LEDs on the my original LED bulb. And I bought these bulbs as replacements for the bulbs I had in there, and I'd replaced my battery, or had I replaced my battery by then? Maybe it took me another lesson before I replaced the battery. But at any rate, I put these bulbs in. They worked for a little while, but then they burned out pretty promptly. So I still have to go through that tractor and figure a few things out, measure my actual voltage that I've got going. I do have a fresh battery in there now, but it may still have some kind of regulation problem. I even tried putting actually when I had these bulbs still, was it before I lost these, or I think I did it before I put these bulbs in. Actually, I put a couple Zerners as a shunt regulator across the wire that feeds these, and I used 15-volt Zerners. I figured, well, if the voltage goes much higher than 15, there shouldn't take that much current to short it down. I only used two 1-watt Zerners. I should have calculated it out. I should have put a small series resistor in front of them, but long story short, they burned up. And I ended up with a short in the whole lighting system now, in the wiring harness somewhere. So I got to revisit the whole thing. It may even be possible that they reverse polarize these bulbs. I hooked them Zerners up without even really checking polarity. I just assumed, the base would be positive and the outer would be negative, but it's possible they didn't go that way. And I see on an autopsy of one of these bulbs, I took one of these apart, and this is what was inside of it. A little metal reflector or heatsink, whatever. But it appears to have 4 little diodes here, which I don't know they're diodes, but I'm guessing they're diodes. It looks like they actually use a bridge rectifier on the input of this bulb. So maybe they anticipate that sometimes polarity is reversed on some of these lights, because this is built for automotive purposes. So maybe that's a stock thing they do on these bulbs when they go LED is, and I think that's why it actually burned up on this bulb, is this bridge rectifier. One of them blew up. And then there's a little inductor for, a little, probably a little buck regulator, and a little chip to drive the buck regulator. Or it may even just be a transistor, and it's got a heatsink tab on it. don't know if it's just a beefy transistor or it's a special IC, but there's also a couple other components on this side. One looks like maybe just a resistor or a capacitor, and the other one looks, yeah, it must be a capacitor. The other one's probably just a resistor. I don't know. But anyway, that's the original circuit. And I got the housing apart and took that circuit out of it. I said, well, I got these high brightness regular LEDs. I'm going to just try to, for a cheapy substitute, I'm just going to try to like take 4 of these LEDs and shove them in this bulb. And, you know, run them at 20 milliamps and 4 in series. That's what I came up with eventually. And I still have to put some liquid electrical tape on the leads of these so they never short out, and glue this together and try to solder that on. But the math I'm going through in the board here is just super simple stuff. I was trying to figure out what it would be if I used 2 LEDs. This is for 12 volt usage, of course. Now, the first thing about 12 volt usage is you actually got to deal with 13.6 volts. And not, well, actually, I should say 13.8 volts, I should say, or 13.6, somewhere in that range. I guess I'm actually looking at 13.8 volts. And that's the top charging voltage. Well, not even the top charging voltage, but that's a typical charging voltage for a lead-acid battery. So whenever you look at a 12-volt automotive system, you're really looking at it like a 13.8 voltage that you really want to design to. And you even have to allow for voltage to go considerably higher than that under worse circumstances, you know, to the 15 volt. I knew my dad had an old K car. It was actually a Dodge. It was a pretty nice car, you know, the ones that were based on the Volkswagen engine. Oh, what was the name of that car? It was one of the more racier of the K cars. It wasn't a typical boxy K car. It was the nicer one that Chrysler made. I can't remember the name of that car. But anyway, I measured the voltage in that car on a really cold day after jump starting it. And it got all the way up to 17 volts. And Chrysler, like many manufacturers, will actually go high on their regulator under cold temperatures. So after a cold temperature start, the battery will actually regulate to a very high voltage, you know, up to 17 volts, just to get the battery charging, you know, the semi-frozen battery charging, warm up the battery and get some charge into it right away. So some cars, you know, under cold circumstances will go considerably higher than that 13.8 volts. Anyway, back to this. I was just trying to look at what kind of current, you know, I was just designing for 20 milliamps, which is a typical LED current. I don't really know the max of these high brightness Cree LEDs I have. I do have a voltage spec on them, which is 13.3 volts. So I assume they'll draw whatever current they want at 13.3 volts. I mean at 3.3 volts. And it's probably 20 or 25 milliamps, which is real typical for LEDs. So I just used 20. This is a nice safe number. So 2 LEDs in series, 3.3 volts each, 6.6 volts. 13.8 minus 6.6 is 7.2 volts. And at 20 milliamps, I'll need a 360 ohm resistor to drop me from that 13.8 to that remainder voltage at 7.2 voltage. So 6.6 voltage for the LEDs, 7.2 volts to drop across the resistor for a 20 milliamp current flow. And I needed a 360 ohm resistor to do that. Likewise, I went for a 3 LEDs. So now, you know, 3.3 times 3 is 9.9 volts. Subtract that from my 13.8 means I have to drop 3.9 volts across my resistor so that my resistor plus my LEDs adds up to my 13.8. And that 3.9 volts times 20 milliamps, or actually I should say divided by 20 milliamps, gives me a 195 ohm resistor. And now for 4 LEDs, same situation. Now I'm only dropping 0.2 volts from my 13.8 because my 4 LEDs will total up to 13.6. And so I'm really only looking at 0.2 volts to drop over my resistor, which gives me a real nice low resistor value. And that's what I wanted because I didn't want to waste a lot of power in my resistors. So I went with a 4 LED setup and got the resistor soldered in, a long wire to the tip here. And this is my remake of a burnt out LED bulb. I'll see how bright it comes out when I actually get it done. I haven't done the tape because I don't want to stink the house up. But I may do that, finish this up soon. The liquid electrical tape will kind of stink up the house. Now would be a good time to do it, so I got enough time to get rid of the vapor before I have to go to bed tonight. But that's a short, look at the kind of things you'd be considering if you're trying to use LEDs in an automotive situation, or in this case, a lawn tractor. And like I said, I still have to go back and do some basic electrical checks in that lawn tractor. And as far as overvoltage, like on a cold day and a Chrysler product maybe that goes high voltage on a cold day, I have accidentally given these LEDs more voltage than the 3.3, and they do survive. It certainly wasn't recommended for them, but I'm confident that even if I had, say, 17 volts in this situation here, it probably wouldn't kill the LEDs for a short-term episode. So this project is somewhat of a failure. I do have the 4 LEDs assembled in the bulb. I still need to run a little bit of glue around the edge here. It's put together pretty well though, with solder and etc. But the bulb is, it's bright, but it's not as bright as the original bulb. It's not as bright as a factory bulb would be. That's about 13.8 volts I'm giving it. That would probably be the headlight bulb. Considerably brighter, I'd have to admit. Even, and I really want the LED solution to be brighter, not dimmer than the original. It's actually not that far off, I guess. But it's a little bit not bright enough. But the real problem here is this is 13.8 volts. If I used it with the ignition off on the battery power, it would rapidly go down to 12.6 volts on a fully charged battery. And oops. If you can tell, my brightness is really down quite a bit at that voltage. And then if I ran it for a while at that and got the battery down to 12 volts, let's say 11.8 or something, I'm even dimmer. On the other hand, they'd go a long time. So I don't know, this is not a great solution. 3 bulbs would give me more stable over those voltage changes. The light would be more stable. Although now I'm starting to think maybe it's not that big an issue. If I was outside, I wouldn't really need full brightness as much as I do when I'm driving the thing, and need to see down the trail. So, well, semi-disappointment. It's not quite as bright as I need it to be. Don't know if I'll do the other bulb this way or not. I might just for it to have it. But I'll probably end up having to buy another high power solution. A factory made bulb. And really, the time I put into making this thing, it's almost worth buying it anyway, because quite a bit of fussing around. Alright, so I'm only drawing 2.5 milliamps at 11 volts. 11.1 volts, which would be just about killing your battery as far as restarting the vehicle. Restarting my lawn tractor anyway. A good car battery should start a car down to almost 9 volts. That's really pushing things, being optimistic. So 14 Um, 14 milliamps at 12.6. At 13 volts, I'm almost 20 milliamps, 19.8. 13.4, I'm 26 milliamps, that's pushing it. And then 13.8, well, let's say 14 volts. I'm pulling 35 milliamps. That's really pushing this bulb. I wouldn't want to see more than, I would think 25 milliamps. So the original circuit, of course, has a little buck converter on it. And there's a couple advantages to doing this. You can actually give the LED less than a full duty cycle of light, so you can actually drive it at its maximum voltage and its maximum current and still not exceed the maximum power over time by having that little dead cycle in your in your pulsed, and you're pulsing it so fast you can't see it pulsing, of course. I'm almost tempted to try to repair these diodes. There's like a bridge rectifier on the input of the thing. Almost tempted to, and they're clearly blown up. Almost tempted. Without surface mount diodes, I wouldn't be able to fit it back in the bulb, though. Not easily. I suppose it's possible. Again, though, more work than it's worth. I should just go ahead and buy a factory bulb. The little buck converter also gives you a degree of self-regulation too, if it's designed right. Over voltage, so it can stay bright at a lower voltage and not burn out at a higher voltage.